Hi everyone, I am JULKA. Today's topic is indefinite integral. In part 14, we'll talk about how to solve integration when we have a different combination of linear quadratic and quadratic is given to us. First point, when we have to integrate dx divided by linear into root linear, we always put root linear equals to t. We'll explain with the help of an example. We have a question integration of dx divided by x plus 3 into root of x minus 1. This is the case of dx divided by linear into root linear. First we put root x minus 1 equals to t. So x minus 1 equals to t square. The value of x is t square plus 1. Now we'll differentiate respect to x both sides and we will get 1 equals to 2t dt by dx. So the value of dx equals to 2t dt. Replace dx by 2t dt, x by t square plus 1 and root x minus 1 by t. Now t cancelled by t. Now we have 2 outside the integration. Dt divided by t square plus 4. We can write this dt upon t square plus 2 square. The formula of x square plus a square is 1 upon a tan inverse x upon a plus c. So it is 2 multiplied by 1 by 2 tan inverse t upon 2 plus c, and the value of t is root x minus 1. So the answer is tan inverse in the root of x minus 1 divided by 2 plus c. Next point, whenever we have integration of dx divided by quadratic into root linear, we'll put root linear equals to t. We can explain with the help of an example. We have a question integration dx divided by x square into in root x minus 1. Put root linear equals to t. So root x minus 1 equals to t and x minus 1 equals to t square. So the value of x is t square plus 1. When we differentiate respect to x both sides, we will get 1 equals to 2t into dt by dx. So the value of dx equals to 2t dt. Replace dx by 2t dt, x by t square plus 1 and the root x minus 1 by t. T cancelled by t. When we expand this, we will get 2 dt divided by t raised to power 4 plus 1 plus 2t square. Now we break numerator 2 as t square plus 1 minus t square minus 1. And now we'll divide this question into two parts. In the first part, we have t square plus 1 divided by t raised to power 4 plus 1 plus 2t square. In the second part, we have t square minus 1 divided by t raised to power 4 plus 1 plus 2t square. Whenever we have t square in numerator and t to the power 4 in denominator, we always divide numerator and denominator both by t square. So we will get in the first part 1 plus 1 by t square divided by t square plus 1 by t square plus 2 minus in the second part we will get 1 minus 1 by t square divided by t square plus 1 by t square plus 2. Now whenever we have positive in the numerator, we make perfect square with a negative sign in the denominator. Whenever we have negative in the numerator, we will make perfect square with a positive sign in the denominator. And now take first part as I1 and the second part as I2. I1 equals to 1 plus 1 by t square divided by t minus 1 by t whole square plus 4. Here we put t minus 1 by t equals to u. Differentiate respect to t and we'll get 1 plus 1 by t square equals to du by dt. So 1 plus 1 by t square dt equals to du. Replace numerator with that du and t minus 1 by t by u. Now the formula du upon u square plus 2 square is 1 upon 2 tan inverse u by 2 plus c1. Replace u by t minus 1 by t. After taking LCM, we have 1 by 2 tan inverse t square minus 1 upon 2t and the value of t is root x minus 1. So t square is x minus 1 and after simplifying we will get 1 by 2 tan inverse x minus 2 divided by the root of x minus 1 plus c1. Similarly, we solve second part I2. In I2 we will put t plus 1 by t equals to v. Differentiate respect to t both sides and we will get 1 minus 1 by t square equals to dv by dt. So 1 minus 1 by t square dt equals to dv. Replace 1 minus 1 by t square dt by dv and t plus 1 by t square by v square. And the integration of 1 by v square is minus 1 upon v plus c2. Replace v by t plus 1 by t, and after simplifying we'll get minus t divided by t square plus 1, where the value of t is root x minus 1. Now I1 plus I2 equals to half tan inverse x minus 2 divided by root x minus 1 minus in the root of x minus 1 divided by x plus c, where c denote c1 plus c2. Next point, whenever we have dx divided by linear into root quadratic, in this kind of question we'll put linear equals to 1 by t. We can explain with the help of an example. We have a question dx divided by x in the root of x square minus 2x. It's a case of linear into root quadratic in denominator. Now here we put linear equals to t. Linear is only x. So we put x equals to 1 by t. Differentiate respect to t both sides and we'll get dx by dt equals to minus 1 by t square. So the value of dx is minus 1 by t square dt. Replace dx by minus 1 by t square dt and x by 1 by t. After simplifying, we'll get minus 1 by t dt divided by in the root of 1 minus 2t whole divided by t, and t cancel by t. Now we'll integrate dt upon in the root of 1 minus 2t. The answer is minus outside 1 minus 2t raised to the power 1 by 2 whole divided by 1 by 2 into minus 2. And we will get answer in the root of 1 minus 2t plus c, where t is 1 by x. So after simplification we will get in the root of x minus 2 upon x plus c. Next point, whenever we have integration of x dx divided by quadratic into root quadratic, we always put root quadratic equals to t. And here we talk about pure quadratic. Now we have a question x dx divided by x square minus 8 into the root of x square plus 1. Is x dx divided by quadratic into root quadratic. Here we put root quadratic equals to t. So we put root x square plus 1 equals to t. So x square plus 1 equals to t square and x square equals to t square minus 1. Differentiate respect to x both sides and we will get 2x equals to 2t dt by dx. 2 cancel by 2. So we will get x dx equals to t dt. Replace x dx by t dt, x square by t square minus 1 and the root of x square plus 1 by t. And after simplification we get dt divided by t square minus 9. It is dt upon t square minus 3 square. The formula of dt upon t square minus a square is 1 upon 2a log t minus a upon t plus a. And replace a by 3, you will get answer 1 upon 6 log t minus 3 upon t plus 3. And replace t by in the root of x square plus 1. Last point of today, if we have dx divided by quadratic into root quadratic, we will put x equals to 1 by t. We will explain with the help of an example. Suppose we have a question dx divided by x square minus 1 multiplied by the root of x square plus 1. Here we put x equals to 1 by t. Differentiate respect to t both sides and we will get dx by dt equals to minus 1 by t square. So dx equals to minus 1 by t square dt. Replace dx by minus 1 by t square dt and x by 1 by t. After simplification, we will get minus 1 by t square dt divided by 1 minus t square whole divided by t square multiplied by in root 1 plus t square divided by t. And further simplification will get answer minus t dt divided by 1 minus t square into in root 1 plus t square. Now it is same as the previous case, is x dx divided by quadratic into root quadratic. So whenever we have a case like x dx upon quadratic into root quadratic, we put root quadratic equals to t. So now we put root t square plus 1 equals to v. So t square plus 1 equals to v square. T square equals to v square minus 1. When we differentiate respect to v, both sides will get 2t dt by dv equals to 2v. So t dt equals to v dv. Replace t dt by v dv and t square by v square minus 1. After simplification, we will get dv upon v square minus root 2 whole square. The formula is 1 upon 2 root 2 log v minus root 2 upon v plus root 2. Value of v is in the root of t square plus 1 and the put value of t equals to 1 upon x, and we will get